can hear about it all across the nation. It's used to make ATP energy. It only takes a few steps and some synergy. The first one, we got glycolysis. It's the first step that you don't want to miss. Then we got the Krebs cycle. We learn about it from the Julie and Michael. Last is the electron transport chain. Makes lots of ATP and makes it rain.
Glycolysis, let's break it down. It'll blow your mind like this. Wa-pow! Occurs in the cytoplasm. To see it would be a phasm. Breaks down sugar into two pyruvates and makes ATP that makes you gyrate. The three main steps that you should know: phosphorylation, lysis, and oxidation. Yo! The step requires a glucose and two ATP. In the end, you get two pyruvate, NADH, and ATP.
Next up is the Krebs cycle, man. Comes after glycolysis, like BAM!
Occurs in the mitochondrial matrix, almost as sick as my mixtape.
First you gotta make a chain. Not that hard, just gotta use your brains.
Starts with pyruvate, NAD, and COA, but COA leads the way.
When the reaction is finished, here's what you get: CO2, NADH, acetyl-CoA, and you're set.
Then the cycle begins with two ATP and electrons, acetyl-CoA, and some carbons to make citric acid.
So on the acid loses carbon, and it gives off CO2. Then comes some NAD plus FAD.
Yahoo!
NAD plus becomes NADH plus H plus, and FAD becomes FADH2.
The cycle ends with COA, but doesn't stop at the end of the day. A quick way to remember is something we learned back in December.
You got no, bleep, no,
And one more time.
No, bleep, no,
This process ends with 2 ATP, 4 CO2. Don't forget 6 NADH and 2 FADH2.
Respiration. Finally, electron transport chains happens in the inner mitochondrial membranes.
Protein complexes, there are 4, and 1, 3, 4 gets a hydrogen molecule.
Score! Complex 1 is where NADH binds till it's NAD plus because it's been oxidized.
So to the ubiquitin, the electrons go, then to complex 3. Show!
Here, AH plus are pumped into the inner membrane space. Electrons go to cytochrome C and hurry, accelerate.
At complex 4, oxygen goes through reduction, makes H2 and hydrogen go through abduction.
Then what can happen at complex 2? FADH2 binds into FAD.
Woo! Overall, the electrons are moved through high electron negativity, creating productivity.
In addition, energy is released and hydrogen is pumped
Like a beat. Finally, chemoosmosis is one more thing you should know. The generation of ATP, let's go. Led by ATP synthetase, uses proton gradients in this chase. Protons are released through an enzyme's channel, and ATP is linked to phosphate, making ATP in panel. So to review in ETC, we got 34 ATP.
Yeah. So. Cellular respiration, yeah. We got glycolysis, Krebs cycle, and electron transport chain. All of this works to make 38 ATP, and that insane.